We have Ben Goerz with new Linux tools for Blue Team and Big Kid Rockets. Ben comes to us as the lead of counter threat management at Kimberly Clark and apparently is involved in protecting the world's toilet paper supply, which, after the past year, I think we can all agree is a very critical role. So, Ben, you can go ahead and unmute and we can go ahead and get started with you.
Thanks. Well, welcome everybody. So what I wanted to share today is a tool set that I use every single day. Linux terminals are a great Swiss Army knife, and I just wanted to kind of work through a couple examples, tempt the gods by doing some actual live demos to show a couple of the use cases I find beneficial. But I really think this should be in everybody's tool set for a few reasons. One is this concept of a non-attrib server, and I'm using that pretty loosely for anybody who's actually had a true non-attrib server. But in this case, I'm talking about having a server that's not clearly related to your organization, being able to have a little anonymity to do some of the poking around you might want to do as a defender without tipping off your adversary that they are being investigated. It's definitely safer than doing the research in-house. If you accidentally execute some malware, you're not doing it inside your network. The traffic, IOC lookups, all that's not coming from internally. Also, another benefit is if you make a whoopsie, or even if you don't, and you're just generating an exhaust trail of IOCs, you're not going to accidentally generate security alerts on yourself. I have had my machine ripped off my desk before and the network cable yanked out because I made a little tiny oopsie, and you don't want to have those OPSEC things following you around. So I'll do some live demos, but you can really run these pretty much anywhere. The host I'll use today cost me about $10 a year. It's a very inexpensive tool. You can use Ramnode, which is one that I tend to like a lot, but also some of the same infrastructure the bad guys use. Vultr, OVH, Hetzner, any of those, the bad guys are using them because they're cheap. You can do the same. Whatever's reliable, it's a good basic tool set. What we'll actually cover today are some of the things on the screen, and don't worry, I've got a GitHub link later in the presentation where you can go pull all this stuff that we'll run through. It's really nothing revolutionary, but hopefully working through some of it, you'll pick up one or two that you didn't know were there, and in the process, maybe learn a thing or two about how to more efficiently use your terminal. So with that, I'm going to go ahead and pull up a terminal window. I've got a little demo terminal here and just run through a few things. So I have a directory full of some files we're going to work through today. And the first one I'm going to look at is sketchy.jse. This is a sketchy JSE file that was referred, maybe looks like malware or something we want to dig into a little bit. So the first thing I'm going to run through is just this file command, which looks at the file headers and gives you basically a quick snapshot of what is this file. In this case, sketchy.jse is an ASCII text file, and we can just run through like head or tail command, take a little look at what's in it. This looks pretty ugly, highly obfuscated JavaScript code. We're not getting a really clear idea of what this does, but we have a decent idea that it doesn't look like much of the legitimate code I've ever seen. There's a lot of obfuscation going on here. So it's not telling us a lot offhand, but it does look a little sketchy, hence sketchy.jse. One other thing I want to show you about that file command, we have another one here, cs-http.pdf. I'm going to run file on that. And you might say, oh, it's going to come up as a PDF or something. Nope, it comes up as a PE32. So we've got a Windows 32 executable because file is looking at the headers of the file, not just the extension. So if you have things that are hiding malware in PNG files or something like that, file can actually give you a much better read than you're just going to have with your eyeball alone. So we know that sketchy.jse file looks kind of weird, maybe something we want to poke at a little more. What a lot of analysts will do, especially new analysts, is take that and upload it to something like VirusTotal. And VirusTotal is a great tool, but Usually it's a pretty rookie mistake to accidentally at some point upload sensitive data to VirusTotal or something that kind of hints that your organization's being targeted. Maybe it has strings of your domain name in there or something. It's definitely not something you want to get in the habit of doing. So a much safer option is to do the SHA-256 sum or MD5 sum, and I'll just show you those quickly. So SHA-256 sum, MD5 sum. By the way, quick little Linux tidbit that I took an embarrassingly long time to learn myself is tab complete. So I have MD5 sum as the command I want to run. I'm going to type in just the first 2 characters of the file name, and I'm going to hit the tab key, and it will complete that. So especially when you have things like really long installer names or something, tab complete is a great way to not have to, hunt and peck for every key. MD5 sum for sketchy.jsc gives me the MD5 sum. Pretty straightforward what these are. But what I can do then is just take that out of my terminal window, pop it into VirusTotal, and now I haven't uploaded the sample. I've just looked at what someone else's analysis has said. So it's a much safer way of doing analysis without giving up your files or accidentally uploading sensitive company information. All I'm giving VirusTotal here is the hash. So I have some analysis. I can see, some of these AV agents are calling it Nemocod. Interesting. Somebody here in the community, some do-gooder here has told me that this sample connects to this IP address. So I'm going to take that and pivot to a couple other tools. Back to my terminal, I have this IP address that I picked up from the VirusTotal analysis. I'm just going to do a quick whois on that. So whois not only works for domain names to give you the registering information, but it also will give you some data about most IP addresses. So in this case, I've just done a whois for the IP address. I can see this is a King Servers branded server sitting purportedly in the Netherlands. Of course, you can do a trace route if you want to trace route that out a little bit. So I know a little bit about this. This doesn't look like a party I maybe want on my network necessarily, just me personally. Maybe you do, I don't know, but I'm getting context. I'm making a guess. So if I want to take that and let's just pretend for a second, I don't have my fancy analysis tools, my elk stack or whatever I really want. Let's just say I'm kind of in the field doing some analysis. Well, maybe I have a firewall.log file. I'm just going to take that IP address and use grep to go look for it in the firewall.log file. I'm going to use the -f switch. That's for fixed. So by default, grep will do a search that can include regex. By using fixed, I'm giving up some of that capability, limiting it to only fixed characters. So I can't do these kind of pattern matches, but it runs faster, especially on big files when you're starting to talk about multi-gigabyte type files. So in this case, I have 6 hits in that file. Now you might ask, how big was that? This is a pretty small sample. I'm going to use word count -l, wc-l for the firewall.log file. Oops, what am I doing wrong here? Word count -l firewall.log. There we go. That file has 3,600 and change rows, and I just picked out 6 really quickly. It could just as easily have 1,000,000. One great thing about these Linux tools is a lot of them were written ages ago when memory was really precious, and they'll run on really big files. They're very memory and often CPU efficient. So great way to kind of do a kludge look up on some of this. I've used this in programs that have had 0 budget for whatever reason. Maybe you have files that you can get, logs you can get, but you don't have the analysis. You don't have any budget to go get analysis infrastructure. You can just, use this with a $10 a year Linux host. So let's pivot for a second away from IP addresses because those are pretty straightforward. let's say I have a domain name I want to look at a little deeper. In this case, differentia.ru is just one IOC I've picked for a demo today. I'm going to use the dig command to do a DNS lookup on it and see this resolves to 2 IPs. Of course, you can do the whois, learn a little bit more about the context. What are those IPs? Maybe a tool's telling me this is, related to an alert that I want to look into. I can get my own context. I don't have to just inherently trust my tools. So the whois tells me this is sitting out in Google Cloud. It's not tied maybe to a service provider that I know I'm doing business with legitimately. Gives me a little idea. Maybe I want to nmap it and just go see what ports are open. You can definitely use some red team tools. Great tool sets like this. You can be a little more flexible in your tool set when you don't actually have the attribution of the IP address to worry about. You can blow away these machines, start them up wherever you want. On that subject of blowing away machines, starting them up, that can be a real advantage too. I've had some investigations, for instance, where there's geo-targeting. One that stands out to me was a phishing email that purported to be from a Mexican, phishing lure, a couple Mexican companies, written in Spanish language. When you investigated the link that it included, if you were in the United States or most other countries, it would send a HTTP 200 response with a fake 404 error page. If you tried it from within Mexico, it would return malicious code. So geo-targeting, and it's really easy and inexpensive to go spin up a machine in Mexico for $10 for a month and go test that theory. And in that case, that's exactly what we did, and it worked out to be an interesting find and add a lot of valuable context for really cheap. So I know port 80 and 443 are open. I'm going to just curl that really quickly to see what's actually out there. What's answering in this case, Synchold by Cryptos Logic. So curl, another great, very, very flexible command, a million switches. Another one in the same line, let's say I'm doing some threat intel, or I'm in one of those situations where I have no budget and I need to build a little IOC search or something like that. I need to get into threat intel IOC processing. Well, one thing I'm going to try here is, oops, not Cryptos, didn't copy the right part. wget is another command in the same vein of curl, except this is just a little simpler and it always saves to disk. You don't have to worry about the switches and all the fancy stuff to direct it. I'm just going to wget rules.emerging threats. So this is Proofpoint emerging threats list, bunch of block rules of compromised IPs. wget it, it pulls it down, and now I have compromised IPs.txt sitting right there. So I can get data onto my machine that way. That's pretty easy. There's a lot of great lists you can pull just that way, dedupe them, track them over time. Super flexible tool. Let's say I wanted to add a little more context. One thing I can do is take a list of data and use other tools outside of the terminal and then bring it back to the terminal another way. One of my favorites is Excel. So what I'm going with here is, if I just do head of that compromised IPs list, it's just a whole bunch of IP addresses, one per line. Well, let's pop that over to Excel and see what we could do, or not Excel in this case, Google Sheets. If I have a list of IP addresses, one of my favorite things to do, you can literally just cat the list of IP addresses, copy it straight out of PuTTY or whatever your terminal is, paste it into an Excel or Excel-like spreadsheet tool, and then use this concatenate command to take that data, in this case, what's in cell A2, I'm inserting into a command, whois space, then that data, and I'm taking the output and directing it to an output file. And I'm going to do sleep1, sleep1 to, sorry, behind me, threat button map decided to turn the sound on. So who is data to an output file, sleep one, so I don't just completely overrun the speed of who is and start getting myself on block lists. The brilliant part here is once you've written that once, you can just double click, it'll copy down. This could be, in this case, it's 3 IP addresses, but it could just as easily be 3,000. Then you can just copy all that back out, head back to the terminal, and paste them in. You can paste them into a script, run the script, let it sit, and just walk away, have lunch, and come back, and it's run however many commands, just whatever the delay timer is. It's a really great kludge way to do large scale work and not even take the time to write a script. Nothing against scripting, but sometimes the troubleshooting can make it more trouble than it's worth. So concatenate, copying back and forth between Excel, really quick way to get some work done. What if I did want to write a script? Bash scripts are very easy to write. I'm just going to use nano to look at what's in this lookup-geo script. So I have an IP list really similar to the one I just pulled down, and I'm running it through a while loop where it's reading in and having an IP variable for every line. Then using curl to hit an API. This is a geolocation API that outputs data in a CSV format, inserting the IP address and passing some fields that it once returned. You can do a lot more than just this, but basically I'm building an API integration straight from the command line here and being able to run it from a bash script. I'm appending the output to this IP result.csv file. And then because this particular API has a rate limit of 45 lookups per minute, I'm using a sleep timer within the loop just so that I reduce my my rate of run. So in this case, sleep's 2 seconds. So therefore, if the script just runs instantaneously, I have 60 seconds a minute divided by 2, I'm running 30 queries per minute or less because the query itself will take time. So that's just how I'm staying within my API rate limiter. Really simple way to do it. So you'll have to deal with permissions. I already have this one as executable. And so I am ready to just run it as such. /lookup-geo. So it will run. And in this case, I'm not suppressing the output or anything. I'm just dumping it directly into the IP result file. So I went ahead and killed that for a second. And I wanted to take that output. I've already run it before. And so I have IP result final, which is the final version of it. I'm just going to cat that out and show you what it looks like really quickly. So it's giving me a location, an AS number, the IP address. So I've successfully run my list against an API, got a big output file. Everything's great, right? Well, what if I want to massage that a little bit? We already looked at grep a little to find the needle in the haystack. Another cool thing you can do is have the hay that's left over. So let's say, for instance, I have an organization that's particularly interested in or particularly based in one country. Let's say my organization is based in India for this example. Maybe I want to find all the IP addresses in a set of traffic or a set of IOCs that are outside of India. Maybe I'm concerned about traffic outside of my own country. Well, for that, we can use grep and use the v switch. And so in this case, I am grepping for every line that does not include India from the IP result _ final CSV and outputting to the IP result - outside India.csv. It ran that quickly. And now if I look at that file, all the stuff from India has been removed. I'm left with just the original. I've used this for separating, taking log files that have a lot of internal communication or a lot of communication with particular known good destinations and removing all that traffic. And so you can take what is a very large log file and start to trim it down by removing known good traffic, and then have a much more digestible set of data to look through. So hopefully that is helpful and has taught you something new in terms of command line tools. Once again, great tool set for basically free. Runs not only in cloud, but a lot of times if you're on site and trying to do some analysis, you can spin one of these up, or you may already have easy access to a Linux terminal and go run this tool set. If you wanted to follow up on anything that we looked at today, github.com/bengoerz/presentations. I've posted all those files so you can go pull it all in. If you're curious, this is the script I've been running through. It just runs through all those specific little commands that I just did. So feel free to go out and grab that, spin up a Linux server, have the same experience, and have a lot of fun. So that's the work fun I do. Let me switch now to big kid rockets. When I was little, I used to love model rockets. I started building them in Scouts, went on to build them at school, fly them to my local schoolyard. I always loved these things. It was just a lot of fun to press the button. And it's, for me anyway, especially more fun to just make crazy creations and try not to blow myself up, which I was pretty successful at. But those have become a lot more fun as I've gotten older and gotten back into the hobby. So what I wanted to cover today is, what they looked like when I was a kid versus what they look like now. Some things you can do as an adult, or just, at any age. The sport has changed quite a bit. When I was a kid, I was flying low power rockets mostly. These are motors in the class quarter A through D. They typically have simple streamers or parachutes and cardboard, plastic, or glue construction. So basically the same stuff. You can probably go to a hobby store and buy a kit for cheap and go fly today. And they are still fun. But what I found to be a lot more interesting is this whole field of mid and high power rocketry, which has kind of evolved over recent years. This is motors where they're E and up, and I'll look at what that means in a second. They have delayed deployment. So they go up, and then instead of popping the parachute way up high in the sky, they will use different mechanisms to basically fall down to earth, either with a tiny parachute, but not the full one, or with no parachute at all, and then deploy the parachute when they're much closer to the ground. What that helps you do is, if there's a wind, it won't catch as much wind and fly away, because as rockets get bigger and they go higher, they have a lot more time as they're coming back down to blow far away. And nobody wants to walk really, really far to go get their rocket back. Also, the materials. There's a lot of fiberglass and epoxy rocket construction, and that opens up some new performance capabilities. But let's look at specifically what are some of these? How do they work today? One question I get a lot is, how big are they? This is not my rocket that you see on the screen. I personally have a bit of a budget limit that I hold myself to. Some of these rockets can get big. And so the real question is, how much do you want to spend? The rocket in this picture, easily, you're looking at minimum several $100s per launch on the motors. Some of these will go up to about $2,000. And that's just what you have in the motors. That's not talking about the rocket itself, the equipment, the details of finding a site to launch a rocket that big. So you can go there, and if you have the budget and the willingness, absolutely a lot of fun too. But I don't personally, because my favorite is this mid-power category. So between the model rockets I used to shoot and the really high power stuff lies this mid-power, where engines in the E, F, or G range. The impulse limits, you'll note that these are doubling as they go. So a B engine has double the power of an A, or at least that's where the limit lies. A C has double the power of a B. So they're exponentially increasing. And what I was shooting as a kid caps out around D. And so the E, the F, and the G, to me, are still a lot of fun. They make a decent sound. They are relatively affordable. And also, you don't have to have any certifications. When you get into high power, there are legal limits on the size of motor you should have. Um, there are different regulatory agencies involved, as well as a couple clubs that we'll go into later, a couple organizations that help you navigate those rules if you do want to go get permission to do that. But the way that basically works is if I want to reach my level 3, I have to first do my level 1 launch, where I am building a rocket, getting a motor, um, and with proper supervision, doing a level 1 launch in a very restricted setting where they actually watch my launch, verify that it was safe, I did everything correctly and safely, and that I recovered my rocket successfully, that it didn't just fall apart. They don't want people building giant rockets that explode in midair and are dangerous to people. So you can do your L1, and then once you've successfully done that, you are cleared to try your L2 and on up to an L3. But dealing with coordinating that isn't as much fun to me personally as just pressing the button and watching it go. So I like to stick to mid power, where there's no real certifications required. In terms of technology, a lot of things have evolved. The black powder engines that I shot in the schoolyard are still around. They're still very popular. You can still buy them in hobby stores, but they have downsides. They're volatile. They deal particularly, they have a problem with temperature swings and expansion and contraction. And on very cold days, it's not uncommon for these things to explode on the launch pad if there's contraction, and you'll get cracks through the propellant that the fire can move up and cause what we call a catastrophic or a CATO explosion. So they have that stability problem. They have relatively low energy density, and just technology-wise, they're about the same basis as a firework, couple thousand-year-old technology. Meanwhile, you can now get into composite motors. These are a different fuel entirely. They're not black powder based. They are an oxidizer with various propellants that are burned. But basically, they are the same technology that's used in the solid rockets that power the space shuttle. They're both reloadable options and single-use options, whichever you prefer. I kind of like single-use because if you lose the reloadable part, that can get pretty expensive. The casings that are reloadable can typically cost 50 to $100, and I don't want to worry about having to lose that if my launch goes a little wrong. So for an extra dollar or two, I'll get one that's fully one-time use and then just throw it away afterward. But the main advantage is higher energy density, and they're more stable, so you can build bigger motors. Another evolution is in recovery. So as I said before, traditional rockets, they would go up, they would pop the parachute, and they would float back down. And that's safe, and it's reliable, and that's great. But especially on windy days or when you're flying to high altitude, you can really have some walks ahead of you. And not only walks, but when your rocket floats down range for a mile or two, the chances of you recovering it really drop. You want to be able, ideally, to see where your rocket lands and not have too far of a walk to go get it. So one way around that is delayed release. These basically use an altimeter to control when the parachute comes out. So the idea here is they go up, the top will pop off the rocket. There's still an ejection charge that will have some event, the nose cone pops out or the rocket separates in the middle. So it's having some difference in drag as it comes down, but it's not popping the full parachute. There's a couple different methods here. The one I prefer is the chute release, and I have one that I can show on video in a minute if we have time. The other method uses pyrotechnics, where you have basically a second rocket launch. Essentially, there's a tiny little igniter with a tiny pyro charge that will pop an extra section that contains a parachute. Either of them works, but for me, the real benefit is the chute release is essentially just a rubber band that gets released electronically, and rubber bands don't tend to fail. Trying to pop the pyrotechnics, that has a failure rate that's a little high, and if I'm gonna have a failure, I would rather either my rubber band burns through or gets jostled up way high in the sky and then the parachute gets released. That's a much safer method of failure to me than to have my second deployment fail while everything's still contained. And in many cases, some people actually just not load an ejection charge into their rocket. They'll rely entirely on the shoot release pyrotechnics. And if that fails entirely, then you can get rockets that just fall straight back to Earth and plant themselves a couple feet into the dirt and tear themselves up. So my goal is to recover my rockets. Shoot releases based on what are essentially rubber bands are the best way to do that for me. Another evolution is materials. This one, you can get into the high-end stuff, and I'm actually going to advocate that you don't, or at least that's what I prefer. Cardboard and glue is cheap and it's easy to work with. And the surprising thing is it's actually Mach capable. You can fly a cardboard tube above the speed of sound, and if you've built it well, it will not tear itself apart. For me, that's good enough, especially since I'm flying kind of middle grade motors. But for some people, it's not. If you really want to fly the big motors, if you want to fly really fast, you're going to need fiberglass and epoxy. It's strong, but it's messy. And you can fly it at high Mach. There's even a couple other more exotic materials like blue tube. Blue tube is essentially a vulcanized or rubberized tube that you can hit something like a baseball bat with it and it just won't deform. So if you want a rocket that's really super recoverable, that's another great material. But all of these are kind of more exotic materials, a lot more expensive, a lot harder to work with. For me, I'm going to tend to stay more toward the cardboard and glue. And glue here is really just the old wood glue. Same stuff, your parents probably had in a cabinet somewhere. It's typically stronger than the cardboard itself, and that's all you need. If the cardboard can fly at Mach 1, then so can the glue. Another evolution is software. This is a program called OpenRocket. It's Java based. You can actually model out your rockets. The rocket here is one that you probably shouldn't fly. This is more of bit more of a thought experiment of, I have a rocket that looks like this. What would happen if I just throw the biggest engine I possibly could in it? Well, in this case, it's going to go 7,000 feet in the air and it's going to reach Mach 2.0. Considering this is a cardboard rocket, I'm not sure it would survive that, but it's a lot better than actually loading it up and causing a big explosion, or having my rocket fail in the middle of the sky and embarrass me. At least now I know what it is. Really, the better benefits here are, it helps you stay within the bounds of your field and the law. So, for instance, my field here in Dallas, there's an altitude limit. And if we have to keep our rockets under that limit per FAA regulations, then we have to know how high they're going to go, and you have to know which engines would exceed that limit. And you can model those in here and figure out what altitude approximately would it go to. Another real benefit is understanding the wind. You can put the wind speed in here, and you can figure out, if I shoot this rocket up, how far is it going to float? It's going to have so long in the air with a certain wind speed, and assuming it goes straight up, which is a bit of an assumption, but let's just say hypothetically, within a margin of error, I'm going to figure out that this thing's going to float, a mile, a half mile, whatever the reality would be, and then see, is that going to keep it within my field, or am I going to be blasting it onto somebody else's property and probably losing my rocket? Lastly, it helps you calculate the stability and some of the other factors about whether your rocket's safe. So the blue here is your center of gravity, and the red dot is your center of drag. And you always want your center of gravity to be in front of the center of drag. Otherwise, the drag will turn your rocket over. So if I had big fins on the front, of course, nobody builds rockets that way because it'd be a pretty dumb thing to do, then the drag on those front fins is going to drag my rocket sideways because the center of gravity would be behind it. Very important to know to have safe rockets. Another metric that this helps you track is how fast will it be going off the launch pad, so that I can have an appropriate speed where the drag on the fins is keeping it straight. If it's not going fast enough, and there's a side wind, oftentimes you can get what's called weather cocking, and your rocket can start to go sideways, and that can cause you to fly off the field as well. So really cool things you can do with this free software, or just invent your own rockets, kind of model out what would be safe, what wouldn't. If you want to go do this, there's a couple great organizations to get to know. The biggest one is National Association of Rocketry, NAR. There's 195 chapters. We have a great one here in Dallas. There's a $5 million insurance limit. I personally am not cared too much about the insurance limits because I'm trying very hard not to go injure myself. But both organizations do carry insurance. Also, the big difference is commercial motors only in NAR, and I'll get to that in a second. But just in terms of the culture of the organizations, NAR is great for beginners. It's great for people who are willing to go buy the equipment to do it right, and safely. They prioritize safety above all else. Now, I think both organizations are very safe, but Tripoli Rocket Association is a little more pushing the edge. They're not as popular in the sense that there's not as many clubs around the country or around the world. They have a little bit less on the insurance limit, but they allow experimental motors, which if you're into that sort of thing is fun. You can actually go legally cook up your own rocket motor in a safe way, and take an oxidizer and what's being burned with that oxidizer and put it all together. And if you're in Tripoli, you can bring it to their launches, and presuming the rest of the rocket's safe, they'll let you launch it, and it's all perfectly legal. Also, just in terms of the culture, Tripoli is geared a little more toward bigger kids, bigger toys, a lot of bigger sport rockets, and not as much of the small stuff. If you have a young kid and you want to take them out to go shoot rockets, either organization's good, but NAR is probably your better cultural fit. If you want to go drop a couple $100 and go shoot some big rockets, I would go with Tripoli. Either way, one of the big benefits is you're going to get to hang out with people shooting their rockets. And when you get into these bigger motors that can cost $20, $30, $40, or all the way up to a couple thousand, I kind of want to let somebody else pay for that. And so I'll go out and take my rocket, spend 10 or $20 a launch, and then go watch some Yahoo with deeper pockets than me go launch a $2,000 motor and enjoy the sport at his expense. So that's what I have on the rocket side. Hopefully, hope you enjoyed it. Go out and fly a rocket. They're a lot of fun. Since I do have a couple minutes, if I could, I would like to go ahead and share one of my favorite rockets. This is an Estes Ascender. Different makers out there these days, but a couple things that I like about this one. First, it's a pretty decent sized little rocket. It's about 3 feet long, 2.5 inches diameter. One of the more minor technical changes is these have screw-on engine mounts. This one's plastic. They do make aluminum. It's actually got a old spent composite motor left in there. One other great thing about this rocket, though, is just the diameter, because the parachute releases I was talking about before, that's what one of those looks like. And they're a little too big for the tiny rockets. So this rocket is big enough that I can fit the parachute release in comfortably. So when this rocket pops out, it's got a nylon parachute, a little more durable than the old plastic stuff. And the chute release fits around it just like that. And you have this little rubber band. Some people actually use rubber bands. Technically, the company sells, fancy, more durable ones. And it just loops around the parachute, and you stuff it back in the rocket. The other thing I like about this rocket is just the size. It uses 29 millimeter engine mounts, which are a size that you can get E, F, and G motors in fairly inexpensive, so you can shoot that whole range with this one rocket. It'll fall down and pretty reliably return the rocket to you. The whole thing costs about $50 retail. You can get engines for this for about $10. The shoot release runs about 100, 150. So, all in with the shoot release to get into the sport, you're looking at about $200. You can go less without the shoot release. Obviously, that's about half of your cost. And either way, mostly I just don't want to spend all day chasing down my rockets that have floated away. So I'd rather spend the $100 for the shoot release. But it's all great tech and it's all fairly new. This whole shoot release, it's only been on the market for about 5 to 10 years now. Before that, the whole delayed uh, delayed release of the parachute was a pretty expensive proposition that was only used by the big guys. But now you can go buy one of these things and be flying within a week. So hopefully you guys enjoyed that and enjoy shooting some rockets. And I'll stop and open up for any questions.
Awesome. Thank you so much for your time and attention to this topic. It's been a lot of fun watching it. I just wanted to clarify one little thing. You had that slide earlier giving the specific impulse of rocket motors. Uh, do you think you could put this into context as to like how big or how heavy a rocket the your preferred range is? How heavy are those?
Sure. So there's calculations in it all. This rocket that I have that flies comfortably on e-motors, it's in the neighborhood of about half a pound total weight. You can certainly go a little higher, a little lower. Really, the best thing here is to throw it in the simulators and figure out just how high it would go given the components. When you're building it, throw it on a scale, figure out what the actual weight is, put that into the software, and then it'll tell you how high it'll go, if it will go at all. But generally, a G motor, you can be launching rockets that are 4 feet tall and 4 inches in diameter and weigh 2 to 3 pounds pretty comfortably. And for me, that's my fun level. At my club here in Dallas, we have launched rockets, 7 inches in diameter and 8 feet tall. And one fun thing is it's been little elementary kids who come out and done it. And you see the rocket and it's 3 times higher than the kid pressing the button to launch it. So that's also a lot of fun. Anybody can really do the math and get into it that way.
Awesome. Uh, in the channel, we have a question. Do you have any tips for people who would want to get into this but live in an urban setting?
Yes. A lot of the rocket clubs will have launch sites. So, for instance, here in Dallas, it's a whole Dallas area rocket society, which is a member of NAR. They coordinate launch sites and they will go out as a club and find a field somewhere relatively close to go shoot at. So, the one we have is about an hour north of Dallas for the big field. They also have some smaller fields that are 20 minutes away from the city center where you can shoot some of the low power stuff. So definitely recommend going and finding a club because they've probably already answered that question.
All right, fantastic. Well, I don't see any other questions coming up. So looks like we're good for now. Thank you very much, ever so much, for presenting to us today, and hope you're having a great con. And look forward to seeing you in the future.
Thanks, guys. Really appreciate the opportunity. Have a great conference.